We're going to talk about another property of a function, and that is onto. A function is said to be onto if the codomain is equal the range. That means that all of the elements in the codomain are being mapped to. So let's take this example that we were using where the domain is all of the students in the computer science department, and the codomain is cars in the parking lot. Notice that the codomain is made up of a Harley, an F-150, a Jeep, and a Prius. I see that each and every single one of the elements in the codomain is being mapped to. This would indicate that this particular function is onto. So let's see what we can do to make it so that it is no longer onto. It would not be onto if I added another car into the parking lot. And there was no student that was mapping to that car. This function is no longer onto because there is an element in the codomain that is not being mapped to. This function is not onto. Another property of a function that is related to onto is the property called everywhere defined. A function is said to be everywhere defined if the domain of the function is equal to the first set, or we'll say set A. So if the domain of function f is equal to A, and here we say that A is the first set, then the function is everywhere defined. This just means that all of the elements in set A are being mapped from. So let's get an example of what this might look like. Let's say that I have a set A that contains 1, 2, 3, and 4. Let's say that I have some set B that contains A, B, and C. And then let's say that I have some set C that contains the Greek letters alpha, beta, and gamma. And then I'm going to define a couple of functions. The first one that I'm going to define is the function that maps A to C. The function is going to contain this set of ordered pairs. The first one is 1 alpha. The second one is 3 beta. And then the third one is 2 gamma. And then I'm going to define a second function G that is going to map B to C. And it is going to be defined by this set of ordered pairs. We're going to have alpha, alpha, and then we're going to have B, beta, and we're going to have C, gamma. Which one of these two would you say is everywhere defined? Well, if I look at the first one, if I look at the domain of the first one, the domain is set A. I can tell because we're mapping the first element is a 1, a 3, and a 2 in our first function. If I look at the set A, 1, 2, 3, and 4, I notice that 4 is never being used or never being mapped from in this function. That means this function is not everywhere defined. There is a value 4 in the domain that is not being mapped from. So let's look at function G, which is mapping B to C. And I notice that there is an alpha, or excuse me, an A, there is a B, and a C. That means when I look at the domain of B, I see an A, a B, and a C. That means that this function is mapping each one of the elements in the domain. Each element is being mapped from. So this one is everywhere defined. So onto is when all of the elements in the codomain are being mapped to. And everywhere defined is where every one of the elements in the domain is being mapped from. So let me know if you have any questions.